Okay, so this was our question, and we need to integrate this, right? And here we are discussing the section of recognizing integrals. So, solution, okay. The first thing is that we know that cos square x is not a derivative. And when I'm talking about integrals, considering derivatives would look a bit weird, but here we are basically working on this concept. So in this case, since cos square x is not a derivative, we need to use something else instead of cos square x, right? And that something can be, we can use this identity. Right, Ranjani? We can use this identity directly. So we would have cos 2x plus 1 by 2 equals cos square x. We will have 1 by 2 plus cos 2x by 2 dx. So we need to integrate this function. So the integral of 1 by 2 is 1 by 2x plus we need to integrate cos 2x by 2 dx. Now again, we are discussing the section of recognizing integrals. So we need to basically identify this derivative, okay? Right. So if we have f dash of x equals cos 2x by 2, we need to think of a function whose derivative would be cos 2x. So when derivative is cos, we immediately think of sine 2x. Now, if the function was sine 2x, the derivative would have been cos 2x into 2. But we do not have a 2 here. So we must be having a 2 here because now if I differentiate it, this 2 would be cancelled, right? So we will not be having a 2 here. Okay, this is clear. But then we have a 2 over here. If we differentiate this function, we would only get cos 2x. But since we have a 2 here, it means we would have this 2 in the denominator as well. Is it clear?
Yes.
So this means that our integral would be, okay. So the way you just told me, that method is absolutely correct, but I think that is more time taking. You can just use this identity directly, and you would not be having the secant the sine square x thingy in your solution.
Yeah.
Because if you have sine square x, then again you will use an identity to simplify it, and that would just waste your time. Okay. All right. So yeah, we are done with this. Okay. Let's talk about a question. The first part says differentiate tan x square. Now, Ranjani, we have already discussed the derivative of this. I want you to tell me the solution. Just guess.
Yeah.
Yes.
Tan x square.
Sorry?
It's tan x square.
Yeah, it's tan x square. You need to differentiate tan x square.
It'll be sec square x.
Yeah, very good, excellent. And derivative, yes, you are telling me correctly, but you always forget about the, derivative of the inside thing.
Sec square x by sec square x and x cube.
Sec square x or sec square x square?
Square x square.
Very good. And you are differentiating, okay? Forget about this, that we are discussing the integration chapter. The question here says to differentiate. So the derivative would be multiplied
2x.
and yeah, it would be 2x. Very good. So this was the first part, and we already knew that the derivative of tan x is basically secant square x, right? This is what we already know, and we have been discussing this as well. Okay, let's talk about the second part. The second part says you need to integrate x secant square x square. Now you have to integrate this, and this is the second part. So you definitely will be using the first part here. Okay. Any idea? Okay. Just look at this part and tell me which function is the f of x and which function is f dash of x.
Dash of x is sec square x square.
Okay. X square.
2x is f of x.
2x?
I mean, tan x square.
Yeah. This is f dash x and this is f of x. So we are clear with this part. Now you have been asked to integrate this okay. Now you need to integrate this and you have to think of this as a derivative, right?
Yes.
Now, if this is the derivative function, like this one, we had tan x square. So our guess would be that f of x is tan x square. This is the initial guess. But we have a 2 over here, right? When we are differentiating tan x square, we would have a 2 in the derivative and we do not have a 2 in this case. So I repeat, if this is our function, if this is the derivative and this is the function, f of x is tan x square and its derivative is 2x secant square x square. This is part A. Here in part B, we do not have a 2 here. We do not have a 2 here. This derivative does not have any 2. So, if I am considering f of x as tan x square directly, the derivative of this is this. And in our question, we do not have this 2. So we need to modify this function such that I get this as my derivative. So what would be that modification?
You can take sec square as tan x and
look, when we had f of x as tan x square, right? The derivative was this. This was the derivative. But now my derivative is without 2. There's no 2 in my derivative. So I will divide a 2 here. And now if I differentiate this, I would get x secant square x square only. Do you get it?
Yes.
And this is what I was supposed to integrate. So this would be tan x square by 2 plus c. What thing are you not being able to understand? What is the thing exactly? What is confusing you? Just tell me, I'll clear it up. Don't worry.
Like, I don't get how you're like dividing it by 2 and
Okay, okay. I'll tell. Do you understand the concept of recognizing integrals?
yes.
Okay, excellent. Now, in my case, this was f dash x, right? This was my f dash x, this function right here. And we had a previous part. So this previous part was basically included because it has a link with the second part. So I guessed initially that my function would be tan x square only. This was a guess, okay? Initial guess was that f of x would be tan x square only, but in previous part I had tan x square only, and the derivative of tan x square only is 2x secant square x square. But if I have tan x square by 2, my derivative would be divided by 2 as well. So I would only have x secant square x square. And in my example, this is what I was asked to integrate. So this was my derivative, and this is the derivative which I want, but I would get it if I have a 2 in the denominator of tan x square, right?
Yeah, I understood.
Now, like you know that the derivative of tan x square is secant square x square 2x. But in your example, this 2 was missing. Now, if you want to get rid of this 2, you need to have a 2 here as well. And then if you differentiate tan x square by 2, you would get x secant square x square. And this is what you had in your question. This is what your integrand was. This is what you considered as derivative in order to do it by the recognizing integrals. Do you understand
Okay.
it?
Yes.
Okay, next example is difficult. Okay, so just don't be scared. This is why I'm teaching you slowly, because these concepts are new and a bit confusing as well. Okay, next question is, again we have two parts. Part A says you need to differentiate cot x. You need to differentiate cot x. And the tip is, which you have been given question, that consider cot x as cos x by sin x. Okay. This is the question basically. And the first part is to differentiate. We don't care about what integration is, what recognizing integrals is. No. At the moment, we are differentiating cot x. Now, cot x is new, but this is the tip. So, in short, you are differentiating cos x by sine x. This is what you have to do. And I want you to help me with this. Okay, so what rule can we use here? This is a fraction. So what rule can we use here?
Quotient rule.
Excellent. We'll use the quotient rule. Very well done. So this is the denominator. This is the g of x. So this would come as it is. We need to differentiate the numerator. What is the derivative of cos
Negative
x?
sine x.
Excellent.
Negative sine x.
And then we have a plus sign or a minus sign?
Minus sine.
Very good. Then the numerator would come.
Cos x. Yeah, cos x and
Yes.
cos x.
Excellent. So this would be cos x squared, right? Divided by?
Divided by sine x square, sine square x.
Very good. Sine square x. Yes. So you will have minus sine square x minus cos square x divided by sine square x. So can you simplify this further? You can use a trigonometric identity here.
Sine square x plus cos square x equals 1. But
very good. Sine square x plus cos square x equals 1. This is the trigonometric identity we will be using. Okay, perfect. So we can take minus common. We'll be left with sine square x plus cos square x divided by sine square x, right? And this is basically
minus 1 by minus 1 by sine square x.
That is minus
1 by sine square x is cosec x.
Yes, very good. Okay, so we are done with the first part. Do you understand the first part clearly?
Yes.
Okay. Let's talk about the second part now. So I will just erase this because I cannot rub the first part. Okay, so the solution is that derivative of cot x is basically minus cosecant square x. Agreed?
Yes.
This is what we have done so far in the first part. Okay. Now the second part says you need to integrate cosecant square x. And how would you do it? Now again you need to use the same method. This is, what is this cosecant square x? Cosecant square x, yes, what is this?
1 by sine square.
No. We don't have to do 1 by sine square because we have already discussed that cosecant square can be a derivative.
Oh yeah, cot x.
Yeah, but okay, we'll go to that part. But what is this? Is this the function? Is this the derivative function? What is this thing? Like we
Dash
are,
effect.
sorry?
Derivative function.
Very good. F dash of x. Excellent. So this is f dash of x. That is cosecant square x. And we need to think of a function which would be derivated, and we end up getting this. Now, initial guess is cot x. We say that, okay, cot x is a function, but when we differentiate cot x, we get minus cos x square. And here we have simply cos x square. So we need to modify this function. So how would we modify this function?
Minus sin x over cos x.
Sin x? Okay. Yeah, minus
Yeah,
sin x over.
minus cos x over sin x.
Okay, but you can say that simply write minus cot x, right?
Yeah, you can, yeah.
Very good. So if you have this, then the derivative would be cos x square. So this implies that integration of cos x square dx is basically minus cot x plus c, right? So basically,
Yeah.
the first part was to differentiate cot x. When you have to differentiate cot x, you don't know how to do it directly. Here you will be using trigonometry. So this was the tip that you are given in question. Cot x is basically cos x over sin x, and you need to differentiate it this way, and you did apply the quotient rule, and you ended up getting minus cos x square x, right? Now, in the second part, you need to integrate this thing. Now, this thing can be integrated. We need to basically do the guesswork. So this is the derivative. We need to think of this as the derivative y, because the underlying concept is that the integral of f dash x is basically f of x. So we think of this as the derivative and we try guessing this f of x. Clear?
Yes.
So basically, we guessed initially that f of x would be cot x. But if f of x was cot x, uh, we would have had minus cos x square x as our derivative. But we had simple cosecant square x. So we need to modify our function somehow. And that was basically by adding this minus sign. Because now if I differentiate it, this would become plus, right? Do you understand this?
Yes.
Are you sure?
Yes.
Okay, very good. Okay, let's do another other question. Okay, now Ranjini, I want you to help me with this question.
Okay.
Again, by guesswork, okay? Again, we are discussing the recognizing integrals section, and you need to recognize this. So you need to think of it as a derivative, okay? I'll just help you with the initial part, and then I want you to attempt this question. Okay, now tell me. You need to recognize this as the derivative. So what could be the function? This is very easy, honestly speaking. I mean, this is not that easy, but you can do it. Yeah. At least you can just guess something. Okay, take your time. but guess something. No idea?
I think we can use the identity sine 2x equals 2 sine x cos x. Can we use that?
Okay, you are saying that we can use the identity. Say it again.
Sine 2x equals 2 sine x cos x.
Okay, so basically this one, right? Okay, and then you can recognize this integral. This is how you are saying?
Yes.
Okay, right. But without using this identity, even then you can try doing it. I'll tell you how. Okay, I appreciate the fact that you have participated, but we'll talk about your method as well. But let's just talk about the easier method. Now, this is the derivative, right? This is the derivative, and we need to think of a function whose derivative would be this. So, what if you have sine square x? We know that the derivative of sine square x is not cos square x, but it is 2 would come here. We'll have sine x, and cos x is the derivative of sine x. So this is how you differentiate sine square x. You know this, right?
Yes.
So basically, if sine square x is your function, if this is your f of x, this is the f dash of x. But in our case, the f dash of x is exact same, but there's no 2 here. So we need to modify our f of x. We need to modify our initial guess. This was the initial guess, but we need to modify it. And how are we going to modify it? If we have sine square x,
Multiplying it with 2.
very good. This, right?
Yeah.
So this is basically f of x and integration of, okay, wait a second. Right. So basically, this would be the integral, right? And we have limits here, pi by 2 and 0. So we need to plug in the limits as well. So we'll have sine square pi by 2 minus sine square 0 by 2. Now this is basically sine pi 2 into sine pi 2 by 2 minus, just think of the sine graph now. This is pi by 2 and this is 0. So at 0, sine is 0. So this would be 0. And at pi by 2, it is 1. So it would be 1 into 1 by 2. That is 1 by 2. Right? Do you understand?
Yes.
100%?
Yes.
Okay. So here's a little quiz for you. Sine square ax dx. So we have already discussed a question of exact same type, okay? You can take your time, but I want you to tell me the answer. Okay, you can take 3 to 4 minutes. I've just written it as a quiz. Don't think of it as a quiz. But yeah, I want you to do it, okay? Because only then I would be able to know if I'm able to explain things appropriately or not, okay? Take your time. I'm here. Just try doing it. Are you able to do it?
Yes, I'm almost done.
Okay, very good.
Is it -1/2
Mm-hmm.
sine ax cos x minus 1/2?
No, the answer is actually different. It's okay, but let's see. Okay, so how have you done it? Is in what was your first step?
Um, My first step was sine square ax. I just did
Mm-hmm.
1 minus cos square x.
1 minus cos square x. Exactly. Okay. I definitely would appreciate that you have tried, but I already told you that if you will use this conversion, you are saying that you have basically used, right?
Yes.
Okay. I would certainly appreciate that you have tried, but look, if you convert it this way and then you integrate this thing, again you will be stuck here. Again, this cos square ax, you are not familiar with any derivative of this type, are you? You aren't, right? Hello? I can't hear you.
Miss, can you hear me now?
Yeah, I can hear you now. So are you familiar with any derivative of this type, cos square ax? No, right? So this means that this was a wrong choice. This is a wrong choice. Okay, you need to do it in another way. And let's talk about that way. Okay. So that choice was wrong. We need to differentiate it. We need to integrate it, but we need to first convert this sine square ax into an other function. This was the right choice. Okay, we know that sine square x is equal to 1 minus cos 2x by 2, and since we had an a over here, so we can always write it down like this. Is it clear? So this is the right choice. Anyways, we will simplify things further and we'll have 1 by 2 dx minus integration cos 2ax by 2 dx. So this would be 1 by 2x minus. Now you need to integrate this cos 2ax by 2. And how would you do that? So you need to do and start your guesswork, okay? You need to think of it as the derivative. You need to think that if you have, sorry, my marker is not perfect. Okay. Now you need to think that if this is the derivative, what would the function be? So if you have cos, immediately you'll think of sine, because derivative of sine is cos, right? So derivative of sine 2ax would be cos 2ax into 2a. But you do not have a 2a here. So you will modify your function and you'll have a 2a in the denominator. I'll explain it if you don't worry. And you have a 2 here. So you will definitely be having a 2 here. Now listen to me. When you have cos 2ax by 2 and you need to solve this integral, you will think of this function as the derivative, and now you need to think of that function whose derivative is cos 2ax by 2. So you will first make an initial guess. And since you have cos 2ax, you will say that, okay, maybe my f of x is sine 2ax. Now, if you would have had f of x as sine 2ax, the derivative of sine 2ax is cos 2ax multiplied by 2a. But in our case, we do not have any 2a here. This means that we would be having a 2a in the denominator, because now if I differentiate it, I would only have cos 2ax. This 2a would be cancelled by this 2a. Is it clear?
Yes.
And we had a 2 in this denominator. So to have to have this 2 in the denominator, you must have a 2 in your actual function as well. So this is how we ended up getting sine 2ax by 4a basically. So this would be sine 2ax by 4a. This is going to be your integral plus c. Do you understand this concept? Are you sure?
Yeah.
Okay, so I
Can we
will.
do another question?
Okay, sure. Let me take out the question then. Let me take out some question. Okay, let's do for cos then. What was this question? Yeah. Is it okay if we do it for this one?
Yes.
Okay. Now,
Isn't this
this,
the same question?
no, we
Oh,
had
that was
sine. Yeah, we have already done a similar question, but we also did a similar version of sine as well. So it's okay if we do it. Okay. Okay. Now look. What is this section? This section is recognizing integrals. You need to do some guesswork here. Okay. So, and what is the underlying concept? The underlying concept is that whatever function you have inside, you need to think of it as the derivative function. And the answer would be f of x. So things are working here in a reverse order. You basically get your derivative function first, and then you need to think of a function whose derivative would be this. So this is how things are working. So again, what is my f dash of x here? Okay, wait. Okay, wait. Okay. So f dash, what is my f dash of x here?
cos square ax.
Excellent. So this is what we are having initially. But we know that cos square x is never seen in the table of derivatives. It cannot be the derivative, okay? So we need to use trigonometry here to convert this cos square x into some other thing. So
1 plus cos 2x by 2.
very good. So we basically will change our integral to 1 plus cos 2x by 2, right? Very good.
Yes.
Excellent. So we will be integrating this thing. Okay, we are still at the question. We have not done anything so far. So we need to basically break down things like this. Now this is 1 by 2x, and we can take this 2 out, okay? For keeping things simple, we can simply take this 2 out, and now things would be easier. Okay. Now let's talk about this part. Now again your guesswork would start. Now you need to think of it as the derivative function. So whenever you have cos 2x as the derivative, what function comes to your mind?
Sine.
Very good.
Yeah, sine 2x.
Excellent.
Sine
But
2x times 2.
okay. Wait. Now if you had sine 2x times 2, your derivative would have been this 2 would come as it is, this 2. And then here you would have another 2 because the derivative of this bracket function comes here. Okay, so this is not the case.
So you divide it by 4.
No. Why would you divide it by 4?
You cancel those.
No, you only have this. Okay, wait. Yeah, if you have f of x as sine 2x, your derivative would be cos 2x into 2. You just have one 2. The other 2 I mentioned because of your guess. You said that we will have sine 2x into 2. So in that case, our derivative would have been 2 cos 2x into 2, right? But in our case, f of x is simply sine 2x. If we had f of x as sine 2x, the derivative would have been this. But what is our derivative actually? This is our derivative. We do not have this 2. So we will divide 2 here.
Why are we dividing it by 2?
Because if you differentiate sine 2x, you will get cos 2x into 2. Agreed? This 2 would come here, right?
Yes. Oh, so
But
you're dividing it by 2 to cancel it.
yeah, to cancel this 2, because this is what you have in your question.
Okay.
So this 1 by 2x would come as it is. This 1 by 2 would come as it is. And this, the integral is basically sine 2x by 2 plus c. So this is 1 by 2x plus sine 2x by 4 plus c. Do you get it now?
Yes.
Okay, let's practice. Let me just give you some random questions. Okay, so we are okay. Secant square would, okay, let's do it. Okay, how would you do this question? This is the derivative.
Yes, f dash of x.
So we need to think of a function whose derivative is secant square 4x, right? So what, sorry?
Tan square x.
No, why tan square?
I mean tan x.
Yeah, very good. Excellent. So you are saying, yeah, this is the initial guess, okay? Initial guesses that our function would be tan 4x, right, Anjali? 4x. Because we have 4, okay. But now then, after our initial guess, we need to think of this function. And just imagine if you had this function, the derivative would be secant square x, 4x and
Times
4,
4.
yeah, but we do not have times 4 here. So
You divided by 4.
very good. We divide this by 4, right? So the
Yes.
integral would be tan 4x
4x by 4.
4 plus c. Okay, don't forget this. Right. Is it clear?
Yes.
Okay. Let me just give you another question then. Okay. Sorry, you are not being able to see my screen, right?
Yes.
I've shared it again. Let me know when you are able to see it.
Yes, I'm able to see it now.
Okay, perfect. So I will clear. Okay. Let's talk about this function now. Okay, how would you do this one?
Be ln of 2x plus 1.
Excellent. Okay, very well done. So what is your initial guess? Your initial guess is that f of x would be ln of 2x plus 1. Very good. But if you had f of x as this, your derivative would have been 1 over 2x plus 1, and the derivative of this bracket function is 2. So
So you have to divide it by 2.
very good. If you will divide it by 2, you will get 1 over 2x plus 1 only, right, as your derivative.
Yes.
Okay, right. Now we only have 4 minutes, so I cannot start new chapter. Let me just find out another question. Hmm. Okay. What about this one? So first step would be to take this 2 out, okay? In order to keep things simple, just take this 2 out. And now this is the derivative. So we need to think of a function whose derivative is sine. So what is the first guess? What is the initial guess? Cos, right? Like
Yeah, go.
there would be a sign problem, but at least you can guess that yes, cos 3x plus 8 would have a derivative of this type, right? But if you had
Divided by 3.
excellent, very well done, and minus
Plus
as
C.
well, minus c, minus. Why? Because the
It's because
derivative, yeah,
yeah,
you get it, right?
negative. Yeah.
Excellent. Okay, very well done. So I'll give a quick recap that when you are recognizing integrals, you are basically using this concept that the function which you have been asked to integrate, you need to think of it as the derivative. And your answer would be basically, if this is the derivative function, you need to think of a function which you would derivate to get this. So your answer would be f of x plus c. This is the only thing you're doing in recognizing integrals, right? And this is the first thing. And the second thing is that if you're having an expression of this type, now you cannot integrate it directly. So you need to use trigonometry to convert such expressions to this form, right?
Yes.
So do you understand it now?
Yes.
100%? Any questions?
No.
Sure?
Yes.
Okay, perfect. So I'll stop share. I'll stop the